Researchers use hypothesis testing to make informed decisions. So when we're stating a hypothesis, a statement about a population parameter is called a statistical hypothesis. To test a population parameter, you should carefully state a pair of hypotheses, one that represents the claim and the other its complement. Okay, when one of these hypotheses is false, the other must be true. Either hypothesis, the null hypothesis, or the alternative hypothesis may represent the original claim. So by definition, a null hypothesis and we use H subscript 0 is a statistical hypothesis that contains a statement of equality. Okay. Such as an equal sign, less than or equal to, or greater than or equal to. An alternative hypothesis which is going to be H subscript A, is the complement of the null hypothesis. Okay. So with that, it is a statement that must be true if H sub 0, or the null hypothesis, is false. And it contains a statement of strict inequality. Okay, so that's going to be you're not equal to, you're less than, or greater than. Okay, so the null hypothesis is read as H sub 0 or H naught, and H sub A, or the alternative hypothesis, is read as H sub A. I will normally just refer to those as null or alternative. All right, so to write the null and alternative hypotheses, we translate the claim made about the population parameter from a verbal statement to a mathematical statement, then write its complement. So these are the three main different ways you're going to see it. Okay, so if your null hypothesis is less than or equal to, your alternative is greater than, because those are complements of each other. Okay, greater than or equal to is complement is less than, not equal to, and equal to are complements of each other. Okay. The thing that's going to change is the population parameter. So we're going to start off with looking at mu, a population mean. Then we're going to look at p, and then we'll look at standard deviation or variance. Okay, so just like what we did with the confidence intervals. Okay, always assume that our mean equals k, and assume the sampling distribution on the basis of this assumption. So, following table kind of talks about that, gives you the verbal statements that you're going to see and how to write them. You guys have been doing this the entire time. So again, those population parameters are going to be mu, p, or sigma squared, okay, depending on the problem. Okay, so if we want to write the claim as a mathematical sentence, then we're going to state the alternative hypotheses and identify which represents the claim. So a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So at least one. Okay, so what would that inequality be? How would you write that? P is what to 0.61? Greater than or equal to. Okay, so that's our claim. P is greater than or equal to 0.61. The reason why it's P is because it's a proportion and it's a percent. Easiest way to remember it. Okay, if it's equal to, is that your null or your alternative hypothesis? Null. So the way we write that, H sub 0 is going to be P is greater than or equal to 0.61. And then your alternative hypothesis. So what's the complement of greater than or equal to? Less than. So P is less than 0.61. And then we always go ahead and write claim to the right of whichever one it is. Okay, because that's going to help us make our interpretation and our decision at the end. Okay. This right here is the first step of everything you're going to do for this entire unit. Okay, second one, a car dealership announces that the mean time for an oil change is less than 15 minutes. Okay, so we know our claim is based off of our mean. So we're going to use mu, bless you. And mu is what? Less than 15. So less than, is that going to be your null or your alternative? Alternative. Because there is no equality with it. And what's the complement of less than? Greater than or equal to. So that's your null hypothesis. Questions with that? Okay. A company advertises that the mean life of its furnaces is more than 18 years. So what would that claim statement be? What's our population parameter? Good. So mu is greater than 18. Is that going to be your null or your alternative hypothesis? Alternative. So then what is your null hypothesis? What's the complement to mu greater than 18? Good. Mu is less than or equal to 18. Okay, questions with that? That's the majority of your homework, is going through and stating those hypotheses. Okay. Okay, we have a little bit more we're going to talk about. We're going to cut this next part completely. On page 6, this is just level of significance. So we know that we reject the null hypothesis when the sample statistics from the sampling distributions is unusual. We've already identified that unusual events are those that occur with a probability of 0.05 or less. When statistical tests are used, an unusual event is sometimes required to have a probability of 0.1 or less, 0.05 or less, or 0.01 or less. Because there's a variation from sample to sample, there is always a possibility that you will reject a null hypothesis when it's actually true. Okay, that's kind of based off what we're not going to go over. It's called a type 1 and a type 2 error. It's not that important. It's just like a vocabulary thing. We're going to skip it. But the key thing here is that you decrease the probability of having an error by lowering the level of significance. Okay. Okay, the smaller the level of significance, the more accurate or the more likely you're not going to have an error. Okay. Level of significance is represented by alpha. Okay. Represented by alpha. All right. We're going to skip that part. Okay, so statistical tests and p-values. We're not going to talk about p-values. We're only going to be looking at rejection regions because that's the same for every parameter that we're going to look at. Okay. So I broke this down and showed you in the table. So we're going to talk about the mean in 7.2 and 7.3. We're talking about p in 7.4, and then variance and standard deviation in 7.5. Okay. The statistics that is compared with the parameter and the null hypothesis is called, I don't remember about that. Oh, the test statistic. Okay. The nice thing about that test statistic, it's similar to what we did with confidence intervals. All right, so one way to decide whether to reject the null hypothesis is to determine whether the probability of obtaining the standardized test statistic is less than the level of significance. So this method is that p-value. Okay. That's what we're not going to be doing. Okay, we're going to be looking at rejection regions, which is a little bit more visual, makes it a little easier to understand. Okay. But if the null hypothesis is true, that's p-value. Sorry, I thought I cut everything we needed to cut. Okay, but there are 3 types of tests. This part will be true for rejection regions. Okay, we have left-tailed, right-tailed, and two-tailed. Okay. The type of test depends on the location of the region of the sampling distribution that favors a rejection of the null hypothesis. This region is indicated by the alternative hypothesis. Okay. Here's the easiest way to remember it. Based off your alternative, which way is your inequality symbol facing or pointing? Okay. That's what determines what type of test you have. Okay. So we look at this first one, the left-tailed test. If you look at that expression and you look at that alternative hypothesis, it's less than. Less than is pointing to the left, so it's a left-tailed test. Does that make sense? Okay. I'm kind of summarizing some of this. So right-tailed, which way is your alternative hypothesis going to be? Any idea? Pointing to the right, it's greater than. That will always hold true. Okay. And then it's going to be two-tailed if it's not equal to. Okay. All right. So let's go back. I'm trying to save you guys some time here instead of being extra repetitive. Go back to those examples where we stated the null and alternative hypothesis. So let's go back to page 4. Page 4. Okay, so looking at the first one, looking at the alternative hypothesis, P is less than 0.61. Left-tailed, right-tailed, or two-tailed? Left-tailed. Okay. What about the second one? Mu is less than 15. Left-tailed again. And what about this last one? Mu is greater than 18. Right-tailed. we okay with determining which test we're doing? All right. Back to wherever we were. Okay, page 9. Okay, this box is going to be something that you basically live in. Okay, sorry, top of page 9. Making a decision. So there's 2 decisions you can make. Okay, we're going to kind of do the first part. We've stated what our null and alternative hypothesis were. And then we're going to jump to the bottom. Okay, we're going to do the middle section of our steps with each section. Okay, because that's going to be the part that changes. But this beginning and end part's the same for the entire unit. So there's 2 decisions you can make. Reject the null hypothesis, H sub 0, or we can fail to reject H sub 0. And based off that determines what we can say about that claim. Okay. This box is what you're going to base everything off of when you make your interpretations. Okay. Failing to reject the null hypothesis does not make something true. Okay. Rejecting the null hypothesis means it's false. So anytime that you reject something, there is enough evidence. Anytime you fail to reject, there's not enough evidence. Okay. So there is enough evidence or there is not enough evidence. And then depending on where that claim is, if it's in the null or the alternative hypothesis, determines whether or not you reject it or you support. Okay. If it's in the alternative hypothesis, you're supporting the claim. If it's in the null hypothesis, you're rejecting it. Okay. And this is one of those things that starts to become more natural as we're doing examples because you can apply it. Okay. So we're going to do this example. You guys come back from lunch. How about that? Okay. Okay. Those of you off site, keep listening. Okay. You guys just stay quiet. Does that work? All right. Okay. So you perform a hypothesis test for each of the following claims. How should you interpret your decision if you reject the null hypothesis or if you fail to reject? So first step, we need to state our claim. The university publicizes that the proportion of its students who graduate in 4 years is 82%. So we have our null, we have our alternative. We're looking at proportion, which is going to be P, and is 82%. So our null hypothesis, P equals 0.82, which is our claim. And our alternative hypothesis is the complement, so not equal to 0.82. Because it's not equal, we do know that that means that we're going to have a two-tailed test. Okay. All right, so we have 2 parts here. How should you interpret your decision if you reject the null hypothesis? So if we reject the null hypothesis, we can say, we're looking at this table. So if we're looking at reject the null, and our claim is in our null. So we're going to be typing out this one right here. So that means there is enough evidence to reject the claim. And then you're going to state what that claim was. So claim that 82% of the university's students graduate in 4 years. What's nice, so say we fail to reject the null hypothesis. So for part B, what's nice is this basically stays the same. I'm just going to duplicate this. And what changes is instead of there is, it changes to be there is not. There's not enough evidence. Other than that, it's the exact same phrase. Okay. Questions with that? Okay, so the only other thing in here is another example. We'll go over the steps for hypothesis testing in the Edpuzzle video that you guys have for homework today. And then strategies. Okay, so a strategy that we have is if we want to support the claim, we're always going to put the claim in the alternative hypothesis. Okay, you're going to have one or two homework problems like that. Okay. If you want to reject it, it's going to go in the null hypothesis. And that kind of bases off that table that I had you guys circle and star, because it's based off how you interpret your information. Okay. All right.